Today we're going to talk about the length of a vector and how to normalize a vector. Normalizing a vector means how do we turn a vector into a unit vector, so to say a vector which has length 1. Usually we denote the length of a vector by this notation here. So we say that that is the length of a vector, of vector v. Well, that is simple, just some notation, and I will find the correct color here. Great. So the length of vector, actually it stems from Pythagoras and the Pythagorean theorem. Because we know that, for example, from Pythagoras, a squared plus b squared is equal to c squared. That is the Pythagorean theorem. If we solve for c, we simply have c is equal to the square root of a squared plus b squared. Likewise, it follows from that the norm of a vector, say a vector in 2 coordinates, v1, v2 in R2. Then we have that the length of vector v is simply equal to the square root of v1 squared plus the square root of v2 squared. That is the length of a vector in R2. Similarly, if we have, for example, a vector in, say, R3, we have 3 coordinates, so we have 3 dimensions. In that case, the length of vector v is simply equal to the square root of v1 squared plus v2 squared plus v3 squared. So actually, for the more general case, if we are in Rn, well, in that case, the length of vector v is simply equal to, well, v1 squared plus v2 squared plus and so on, all the way up to the nth term squared. And I can give a quick example. Well, say that we have a vector in R3. Say that v belongs to R3. And suppose we have the following coordinates of v equal to minus 3.2.1. Is in R3, of course. Well, in that case, the length of vector v is simply equal to minus 3 squared plus 2 squared plus 1 squared, which is equal to the square root of 9 plus 4 plus 1, which is equal to the square root of 14. So the length of vector v is simply equal to the square root of 14. Let me introduce to you the meaning of a unit vector. So a vector of norm 1, so if we have a vector v is equal to 1, well then v is a unit vector. So if we have a vector of norm 1, the vector is called a unit vector. And such vectors are useful for specifying a direction when length is not relevant to the problem at hand. You can obtain a unit vector in a desired direction by choosing any non-zero vector v in that direction and multiplying the vector by the reciprocal of its length. For example, if v is a vector of length 2 in R2 or R3, then 1 divided by 2 multiplied by v is a unit vector in the same direction as v. Let me put it in more general terms. Suppose that if we have a non-zero vector, vector is different from 0, but it is in Rn, then u equals to 1 divided by the square root of v, the norm of v multiplied by the vector v itself, defines a unit vector that is in the same direction as the vector v. So we obtain the same vector, so to say, just with norm 1. So the length is now length 1, but I mean, it's essentially the same vector. Besides that the length is different because it is in the same direction and so on. I can give you an example. For example, so now I want to show you how you can turn a vector into a unit vector. Suppose we have the vector v is equal to 2.2 point minus 1. So we have a vector v with 3 coordinates, 2.2 point minus 1. And we want to figure out how can we turn this vector into a unit vector. So we want to figure out, is it possible to make this vector give it a distance such that the distance is 1. So we want to like manipulate the coordinates of the vector. Okay, well, if we just take the vector here, we just take the norm of the vector v, we simply end up with 2 squared is 4, plus 2 squared is 4 again, plus 1, which is equal to the square root of 9, which is equal to 3. So obviously vector v in this case is not a unit vector. But if we use the formula here, we can turn vector v into a unit vector. So how do we do that? Well, we simply say that u is equal to 1 divided by the norm, which was given here, which is 3, multiplied by the vector v, which is here, 2 dot 2 dot minus 1. Okay. Well, what do we do here? We simply say that is equal to 1.3 multiplied by 2, 0.1 multiplied by 2 divided by 3, 1 multiplied by minus 1 divided by 3, which is equal to 2.3 divided, dots 2.3 dots minus 1 divided by 3. Okay, so this is we have now normalized vector v, which means that we have turned vector v into a unit vector because now vector v has length 1. Okay, so what should we do? Well, it's pretty simple because we can say, is this a unit vector? Yes, it is a unit vector because if we take the length of the vector here, we end up with 4 divided by 9 plus 4 divided by 9 plus 1 divided by 9. And this is equal to 9 divided by 9. Square root of that is simply equal to 1. Okay, so we have found a unit vector. And essentially we can say that, well, this vector is the same as just a scalar of the original vector by dividing it by 1 divided by 3.